This is the third lab for MEC-140, Introduction to Robotics. And what we have here is the Arduino, which is hooked up to a single red, green, blue LED. And the LED is blinking different colors by changing the outputs that are activated through the Arduino software. As you can see, the LED has one common connection that goes to ground and has three connections that go to various outputs, and each wire designates the color of the LED. And this is all ran on a program which can be seen written right here, and on the computer screen is just a continuation of this program. The first few steps right here just designate variables, then we set the pin modes to output, and using digital write we can set each pin accordingly which one to be on, and so we just vary the different ones that are on. We can have two on at once, and that'll change the color of the LED, and we just add the delay to keep the light on for a specified amount of time. This is lab number 3, objective number 2. In this part of the lab, we are simulating a night rider type light configuration where the light is bouncing back and forth on both ends. And we did this in a previous lab, however we're using different programming to make this happen in this lab. And right now you can see all the LEDs are hooked up to various pins on the Arduino board, and they all have resistors and are connected to the common ground on the breadboard. And you can see the program that we're using is a 4, which designates a variable, designates a value for which the variable will be executed for, and it designates the increment or decrement that we have in it. And we have the digital write high, which turns the light on, and delay, which goes on for a certain amount of time. And with the program, you can see all the integers being named to the according pins, and we turn all the pins to outputs. And with this very simple loop with the 4 commands, it only takes 2 separate commands. We have the digital write high, which turns on the LED, and right afterwards we have digital write low, which turns off the LED. And we have a duration variable which can change to change the speed of the light coming on and off. This is part 3 of lab 3, and as we can see we have the LED, a limit switch which is used as a push button, and both of these are hooked to the Arduino board. And we have the pins 3 and 4 are being used. 3 is the input, which is connected to the switch, and 4 is the output, which is connected to the LED, and both are connected back to ground. And as we can see, when we press the switch, the light comes on. We release the switch, the light goes off. See the program that we're using, in which variables are defined. We have pin 4, which is the output, the LED pin, pin 3, which is the input, which is the switch, and we have one more value defined, and we can use that later in the program. In the setup, we see pin modes. We set 4 to the output, which is the LED. 3 will be the input with the switch, and we have the pull-up command, which utilizes the resistors in the Arduino board rather than having to wire up a resistor. And this pull-up resistor helps because the inputs are high impedance, and the inputs will change. Without that pull-up resistor, the input will pick up noise in the room or pick up capacitance from other pins, and that'll make it look like the input is being activated randomly, when in fact it's just picking up electrical noise. And so we use that pull-up, and that'll stop that from happening. The only downside is that it flips everything, so when the input is not activated, it'll be in a high state. When the switch is not activated, when the switch is activated, it'll be in a low state. So we combat that later in the program by flipping and doing the opposite of what we would normally do. In the loop, we have digital read, which is reading the input, and then we have our if-else statement. And we can see that if the push button is pressed in, which will be a high input, then the digital write LED pin will actually be low, and that's because of the pull-up resistor. If we weren't using the pull-up resistor on the Arduino board, that would be high, and the else statement would be low. But since we use the pull-up, we switch those around, and that will get us the desired effect. And lastly, we have the serial print and a delay, and that just monitors our input state. And as you can see, without the switch being pressed, it continuously is reading a 1, but when I push the button, you get zeros. Release it, goes back to 1, and we can go back and forth with it, and you can see how it changes in that delay half a second. If we push the button fast enough, we won't see any change in the output. This concludes lab number 3.